COMSOL Multiphysics Lecture 5 Eigenfrequencies or natural vibration. Sometimes it is called model analysis, for example in ANSYS. So now anyway, it is natural vibration. We can open an assembly C program file, SolidWorks Corporation, SolidWorks simulation example, and use large icon and filter it with assembly, and you can easily find the shaft assembly. Open it and save the file on desktop instead, so you don't mess up the original. Now I'm going to work with the live link mode instead of docking mode, so make sure that the preparation step of loading the program is done. So in COMSOL, I'll make sure that the live link is toggled on. So now I'll open COMSOL and enter COMSOL environment. In the live link mode, both softwares are opened, and it is better way of running COMSOL, especially when the system software is lower. If your computer is older, I suggest that you use live link mode instead of docking mode. So I'll open the 3D problem, and for now I will choose structure mechanics, solid mechanics, add. Instead of choosing statics analysis, as I said, in solid mechanics there are statics, dynamics, natural vibration, and buckling. So I'll choose eigenfrequencies, which is natural vibration procedure. And for the first step, I need to load the 3D part or the geometry from SolidWorks, synchronize, and this is the geometry that is imported from SolidWorks. So I have finished with the first step. For the second step, it is material. First of all, I'll add a alloy steel 4340 AISI. So this material is SNCM 439 in JIS system. In Japanese material system, it is SNCM 439, and in AISI is 4340. So this is an alloy steel. I'll make it the shaft, this material. And then for the bearings, I wanted to choose bearing bronze, but there is no bearing bronze. I'll choose copper. Okay, and select these two bearings. So this is a way you can define different materials for different parts. Okay, we have finished with the second step. For the third step, I'll make it finer and build the mesh. And now for step 4, boundary conditions, I'll fix the surfaces. I'll make it zoom in. Okay, I'll select this face, this surface, this one, to fix the 4 holes. And in natural vibration, you don't have to apply any load. So Now I'll enter step 5. Before I run the study, make sure that you change the number of frequencies that you want the software to calculate, and I'll leave it as 6 frequencies and 6 mode shapes. So I'll go ahead and compute, and now I have finished with the step 5, and now enter step 6, which is the result, and the software will calculate 6 frequencies for me. I'll wait a little bit to let it calculate. Actually, in COMSOL, you can also draw the model here in Build All geometry part. There are 3 ways you can generate geometry. The first is to build inside COMSOL. The second is import from CAD system softwares. For example, IGES file or parametric files. Import as a, for example, IGES format. So this is the result, and I can choose from the 6 different frequencies. For the first frequency, it is 1232 Hertz. So I can generate an animation, and for the animation I can simply play the animation, or here you can play the animation. So this is the mode shape, and you can always choose other shapes to make it for example, in the result mode shapes, we'll choose another, for example, the 5th frequency. You can plot the mode shape and play the animation. So this is the eigenfrequency in COMSOL analysis. In COMSOL, it is called eigenfrequencies. In theoretically, it is called natural vibration, and in, for example, in ANSYS, it is called model analysis. So generally, we don't place any external load on a natural vibration problem, and if we do try to impose a stress or a load on the system, for example, I'll add a force here and make it a concentrated load. The type of force, the surface of load application, and also the direction of the force and magnitude of the force. And since external load is ignored or blanked out, for example, in ANSYS it is blanked out, in SolidWorks simulation the external force item is ignored. But we can see how COMSOL handle external force. We can calculate again. And we will see how COMSOL handle the external force in eigenfrequency problem. Since COMSOL is not like ANSYS, ANSYS blank out all the force application menu, so you cannot place any load in model analysis form. And in COMSOL, even in natural frequency or eigenfrequency procedure, you can place an external load to it. So we can see later that whether the natural frequency will shift a lot under such external load. And this is a way to understand how a software is written. So you get familiar with the software more. So you can see that the frequency basically does not shift. So it is 1232 under stress, under external load. So now, if the boundary load is removed and we calculate again, remember that under external load of about 100 kilogram, the first frequency is 1232. Now, without external load, the frequency is very close. So we can see here that in COMSOL, external load in natural frequency analysis or eigenfrequency procedure, the external load is ignored. So in all the softwares and in theoretical also, you do not place a load on a natural vibration, because the term on the right of ordinary differential equation, which is external load, is equated to 0. So some softwares, for example SolidWorks simulation and COMSOL, ignore it. For example, now it is 1232. So the frequency is the same, right? Whether we place external load or not, the frequency does not change. So in COMSOL, for natural vibrations, the external load is ignored, just like in SolidWorks simulation. So this is how COMSOL is written.